Today we are going to learn ambient light reflection, diffuse reflection and specular reflection in illumination model. So ambient light means the surface are getting light from various reflected source. For example, in your room at a daytime you switch off your light, but still you are getting light in the room from different reflected places. So intensity on a particular place O, the pixel intensity would be IAK, where K is ambient reflection coefficient that depends on material of object, and that lie between 0 to 1. And IA is the intensity of light, the ambient light. The ambient light is assumed to be present equally on all surfaces from all directions. Next is diffuse reflection. In diffuse reflection, like dull surfaces, Lambertian surface, the amount of light seen by viewer is independent of viewer direction. For example, in this seat, either we see from this place, this side, to view this content, or to this side to view this content. It is in same for me. So diffuse reflection, the intensity of pixel at this place is I equal to IS KD cos theta. Cos theta is angle between source of light and normal vector at point O. And this cos theta is can be replaced by normal vector and source of light vector dot product. And KD is lie between 0 and 1, and theta can be lie between 0 to 90 degree. For generating more realistic image, if there is some object and that object is generated or viewed by some ambient light as well as diffuse light. So diffuse light, like in your room, there is a point source like your tube light, and from that point source you are able to view an object in your room. So that is a diffuse reflection example. For getting more realistic image, ambient and diffuse, we combine it. So I equal to IAKA plus the diffuse value, which is n dot s. And if there is a light source in diffuse reflection and we are able to view some object, so there is a distance dl. Okay, so the intensity of light source, which is I have taken as a IS, may be attenuated when it reaches to object. So the intensity would be multiplied by some attenuation factor, and IS KD n dot S. This is intensity for diffuse reflection. And this attenuation factor depends on distance from the object. So it can be 1 upon dl ka square. Okay. So exponentially it falls down the intensity. So here the more realistic image, the total intensity would be ambient light plus this diffuse reflection. So this is diffuse reflection, normally happened with dull surfaces like paper. Next is specular reflection. Specular reflection happened at a shiny surface. And if this is a source, light source, and it is the R, that is reflection vector, and both angle as theta. Well, like in mirror, when you throw some rays on the mirror, with same intensity you will get reflected value. And this is the viewer direction. Viewer, you can imagine it as camera also. So in the specular reflection, intensity at point O, I will be is kd cos ki power n alpha, where n is a specular intensity and alpha is angle between reflection vector and viewer direction, and that r can be 2n n dot s minus s, and cos alpha equal to r dot v. So in the specular reflection, we calculate the shiny surface. There is a model, Phong illumination model, and it says the intensity of any realistic image is ambient light reflection plus diffuse reflection and plus specular reflection. It is combination of all three reflection intensity. Okay. So from ambient, I equal to Ia Ka, where K is the coefficient, depends on material of the object, and this is diffuse reflection, this is specular reflection. We add it for getting Phong illumination. Thank you.